Hey guys, welcome to the help video for quiz 5.15. Alright, so to be successful on this quiz, you need to know about parallelograms. So here we go. Here's some information about a parallelogram. First of all, it's just a flat shape, and the opposite sides are parallel and equal in length. So EF has to be parallel to HG, and EH has to be parallel to FG. So the opposite sides have to be parallel for it to be a parallelogram. The opposite sides have to be congruent. The opposite angles are congruent. So this angle up here is going to be congruent to that one, and this one's going to be congruent to that one. The consecutive angles are supplementary. So E and H would have to add up to 180. Consecutive means next to each other, one right after the other. So F and E would have to equal 180. F and G would have to equal 180, and so on. And also the diagonals have to bisect each other. Remember, bisect means to cut it in half. So these are your properties of parallelograms. Now let's check out the quiz. It says that this is a parallelogram and that EJ, let me color code that, is x squared minus 4. And then JG is 3x. And we know that in a parallelogram, the diagonals bisect each other. So we know that that's cut in half. We know those two pieces are going to be equal to each other. So what we can do to solve this is we can set those two equal to each other. Now there's actually a lot of algebra involved in this, so let's do a bit of an algebra review. Alright, first of all, we have x's and x squareds. So we can't just isolate x. We have to get it all equal to 0, and then we have to either factor it or use the quadratic formula. So to get it equal to 0, I need to get rid of 3x, so I'm going to subtract 3x from each side. On this side, I would get the 0, which is what I'm looking for. Over here, I don't have any like terms. So I'm just going to write them in order. X squared, then my negative 3x, and then my negative 4. So now I have this trinomial. You can either factor it or you can do the quadratic formula, whichever way you prefer. I will go ahead and do the quadratic formula for you. So for quadratic formula, you need to identify your A, your B, and your C. Oops, I just wrote B again. Jeez Louise. So my A is 1, my B is negative 3, and my C is 4, and then I'm going to plug it into the quadratic formula. Negative B plus or minus the square root of B squared minus 4AC all over 2A. So here I go. I have negative, and then I'm going to plug in my B, which is a negative 3, plus or minus the square root. And y'all, when I plug things in, I always put them in parentheses. That way you know you're not going to get any calculator errors or anything. It's just better to have it in parentheses. Alright, so now let me pull up the calculator and show you what this would look like. So if you have the super awesome TI-30XS, you can type it in exactly how it looks. You can hit the fraction button and then type in negative 3 in parentheses plus, and then we want a big old square root. And notice this says plus or minus, but I just do the plus first, and then I'll go back and I'll change it to a minus. Negative 3 squared minus 4 times A times C all over 2 times A. Okay, so one of my answers is going to be x equals 4. But this is going to have two answers. Anytime your exponent is x squared, that tells you that there's two answers. So there's going to be another answer. So what we have to do to figure out that other answer is we need to type it in with a negative sign. So I'm just going to highlight and get that whole thing back in there. And then instead of this plus sign here, I'm going to change it to a minus sign. And so my other answer is negative 1. Okay, so we have both of these answers, and we need to go back and see which one makes sense. So let's plug it in. Our ultimate goal is to find the length of EG. So we're going to plug it back in, and it doesn't matter whether you plug it in for the 3x or the x squared minus 4. It should give you the same thing because those two things have to be equal. So I'm going to substitute it in for 3x because that looks a little bit easier to me. So I'm going to take 3 times 4, and I'm going to see what I get. And I'm also going to take 3 times negative 1, and I'm going to see what I get. All right, so 3 times 4 is 12. 3 times negative 1 is negative 3. All right, well, you can't have length JG be negative 3 units. That just doesn't make sense. You can't have negative lengths. So this would be positive 12, which means this one is also positive 12. So the whole thing, if you add it together, is 24 units long. Let's try the next one. All right, so this one is a proof. All right, we are given that this is a parallelogram, and we're trying to prove angle N is congruent to angle L, and angle M is congruent to angle K. So in this step right here, we have K plus N equals 180. Let's look at that. K, I'm just going to mark it. This angle and this angle equals 180. Well, I have to ask myself, why do those equal 180? If you think about this, this is a parallelogram, so we know that this side is parallel to this side. And then we can imagine it being cut by this transversal. So these two angles are actually called same side interior angles. Those are angles that we already learned about. We know same side interior angles are supplementary. So the reason these angles add up to 180 is because they are same side interior angles. So I'm just going to draw a line up here because I don't want to type all of that. All right, and that's true for all of them. You could check L and M. Those are same side interiors, same as K and L. So then the next thing they do is they say, well, since they're all equal to 180, they took this part and KL, and they set them equal to each other. Because we know they're both equal to 180, we also know they both have to equal each other. All right, and they did the same thing down here. So they substituted that in. Basically, they just took this and plopped it right in there, substituted it. All right, so then we have the measure of angle N equals the measure of angle L. So we got to go back up here and ask ourselves, how did we get, I'm going to change colors because I got a lot of weird lines going on here. How did we get from this statement down to this statement? And if you look at it, we have the measure of angle K on each side. So we could subtract off the measure of angle K, adios, and we would end up with the measure of angle N equals the measure of angle L. So we're actually subtracting, and if we check the next one, M and K, notice we're subtracting the measure of angle L on this side, and we're subtracting the measure of angle L on this side. Those cancel, and we get the measure of angle M equals the measure of angle K. So to do this step, we are using the subtraction property of equality. And then for the last one, let me change colors again. We have to ask ourselves, okay, how did we go from this step down to this step? So right here we said the measure of angle L equals the measure of angle N, and now we're saying angle L is congruent to angle N. I said that backwards, but. So we're saying because their measures are equal, they're also congruent. That is the congruence postulate. So the angle congruence postulate would go right there. All right, the next one says, which statement proves that quadrilateral is a parallelogram? So we just have to go back to our information that we know. We know the opposite sides are parallel and the opposite sides are congruent. We know opposite angles are congruent. We know consecutive angles are supplementary. And we know the diagonals bisect each other. So we're just going to mark every one that's true. So a quadrilateral DEFG has opposite angles that are congruent. It says it right there. So there we go. That one's a true statement. Quadrilateral DEFG only has one set of consecutive angles that are supplementary. That's not true because all of the consecutive angles have to be supplementary. Quadrilateral has diagonals that bisect each other. Yep, says it right there. That's a true statement. Quadrilateral has only one set of opposite sides that are congruent. Both sets of opposite sides have to be congruent, So that is not true. So it's just those two. All right, this one says, what is the measure of angle DAB? So let me trace that out. DAB is this angle right here. Notice that we're given this angle is 96, and these two angles are those same side interior angles, or the consecutive angles, so we know they have to add up to 180. So we could say 96 plus angle A equals 180, which simply just is a fancy way of writing out the equation in order to say that you're going to subtract 96 from 180 to figure out your answer. So the measure of angle DAB is 84 degrees. All right, and then the last one, we have another proof. All right, so the coordinates of point C are something. Well, it's right here. So let's go back. To get this distance, this one is A units long. All right, but we still need, in order to get to C, we still need the rest of this distance. So we have to ask ourselves, well, what in the world is the rest of that distance? But if you look up here, we already know that that is B, and so the rest of this distance is also B. So to get all the way out to the C using the x-axis, we would have to do A plus B. We would have to add those two distances together to get out to that coordinate. And then we know the height is C because the height of that one is also C. So this one's located at A plus B, comma C. All right. Then it says the coordinates of the midpoint of diagonal AC are something. All right. So let's check out our diagonal AC. In order to find the midpoint, you have to use the two endpoints, and you have to plug it into your midpoint formula, which is x plus x divided by 2 and y plus y divided by 2. Now notice they already have the y value done for us, so we don't even have to do that part. We just have to do x plus x divided by 2. So I'm going to label my ordered pairs. If I did my x plus my x, I would have 0 plus a plus b all divided by 2. So that reduces to just a plus b divided by 2. All right, and then it wants us to find the coordinates of the diagonal BD. So we're going to do the same thing. Let me pick out a different color. So if I want to find the coordinates of the midpoint, again, I have to use the endpoints of the line. So I'm going to use those two coordinates. And it already gives me the x value, so all I have to do is the y portion of the midpoint formula. So I'm just going to do y plus y divided by 2. So I'm going to label my y values, and I'm going to plug them in. C plus 0 divided by 2, which gives me C over 2. All right, and then it says AC and BD intersect at point E with the coordinates, and so they've already given us the coordinates at point E. And then by definition of the midpoint, AE, so let's look at where we're talking about here. AE is congruent to what else? Well, if we're dealing with a midpoint here, AE has to be congruent to AC because that's E is the midpoint of that line. So, I said that backwards. I meant EC. And then if we look at the other line, it says, let me just pick a new color, that BE, so this part, is going to be congruent to, well, since we know E is the midpoint, it's going to be congruent to that part, which is DE. If I could get back to my pen, there we go. And therefore, the diagonals bisect each other. All right, good luck on your quiz.